Hello, we are going to talk about now the unit vector and collinear vector. So let's first talk about the unit vector. Let's say to make this, well, here, let's do this. Imagine you have some vector, right, in space. And let's say that it's whatever this length right here, its magnitude, so its length, let's say it comes out to 10, right? And we want to change it into a unit vector, right? So what would we need its length to be? We'd need its length to be scaled down to a length of where it's 1. I know this isn't to scale, but that's what we want to do. So think about it, whatever its magnitude is, we want it. What would we have to do to scale this down? Well, I want it to be, to pretty much divide it by its magnitude, right, whatever this vector is. And so, for instance, so if you see a vector, well, let's look at this one right here. If you look at, I don't want to do that right there. If you look at its length, right here is its components, right? And this is A and this is B, right? Now, I'd have to scale it down to a certain amount, right, to make it happen. And what would that amount be? If this was vector U, right? Each component, these are similar triangles, right? They'd have to be scaled down. So each component of this vector, so if this, well, let's make this vector v, right? If this is vector v and the unit vector u, if I wanted to find the unit vector of this vector v, I'd have to scale it by its magnitude. So I'd take 1 over the magnitude of v, right, of its components a, b, right? And that would give me a unit vector of the unit vector of this vector v that I have right here. So the proper way to write it is the unit vector. If we were to write it shorthand, we could say v over the magnitude of itself, right? That will give you the unit vector of this vector right here. Another way to write this is, since the magnitude is equal to, well, if we let v equal its components v1, v2, right, then this vector right here would be v sub 1 over square root of v sub 1 squared plus v sub 2 squared, right? And then its component down here would be v sub 2 over v sub 1 squared plus v sub 2 squared, but I'd take the square root of it because that's that magnitude that's scaling through this vector. So that's the way that we write that. Good. Now that's what the unit vector is. So, and that's my explanation. Now, if we're going to talk about something that's collinear, right? No matter what happens if something is collinear, if two vectors are collinear, what's going to happen is you're going to have u, and you're going to be able to write some scalar lambda times some other v. If you can always show this, and it could be any other direction too, it could be positive, negative, any vector right here, then they're going to be collinear. And you can simply see that, like if I had the vector 1, 2, well, that's going to be collinear to the vector 2, 4, right? Good, because I can write this as 2 times 1 half, 1, 2, and these two vectors are collinear, and vice versa. So there you go. So that's what the difference between those are the two concepts that we're going to cover right now. Is we went over collinear vectors. If any time this happens, this is that's collinear vector, and the unit vector we can solve by taking whatever that unit vector u of length 1, right, is going to be the v, and scaled. You're going to scale it by its own magnitude to get a unit vector, and it's going to help us solve some problems. So let's look at the first one. It says, given that vector v is the vector 3, 4, find all possible collinear vectors with magnitude 2. So let's think about it. We want to find that it's collinear with it. So I can have some scalar times 3 times that, then I take its magnitude and I want it to come out to be 2, right? So what does this come out to be? This comes out to be the square root of, I'm sorry, first I got to figure out what the unit vector is going to be. So let's see. What would the unit vector, so if I go the magnitude, the v, if you notice the magnitude of this is going to be 5, right? Right, that's that 3, 4, 5, right, triangle. You go ahead and check, right? And then now I want to go ahead and find, and then if I make this into a unit vector, right, I need to make it a unit vector to find its collinear vector, right? So the unit vector of this guy, right, is going to be basically 3/5 over 4/5 after I scale it by 1/5 this vector here. This gives me the unit vector. Now I'm going to find something with magnitude 2. So that's where I'm going to take I'll use the scalar lambda times the vector 3/5, 4/5, right? And then I want to take its magnitude, and I need it to come out to be 2, right? So, and here we go. So, right there. And now, so what's the magnitude of this? This is going to be the square root of, it's going to be 3/5 lambda squared plus 4/5 lambda all squared, and that has to come out to be 2. Square both sides. This is going to be 9/25 lambda squared plus 16/25 lambda squared, and this would be, when I square both sides I get 4, right? Keep going, and you can see these are like terms. I could put them together, and it's going to be lambda squared, because 9 plus 16 is 25. 25 over 25 is 1, equals 4. And then take the square root, and I'm going to get lambda is going to be plus or minus 2, right? Plus or minus 2. So what does this tell me? I can scale this this unit vector right here that I found of 5 in 2 ways. So where lambda is going to end up with a magnitude of 2. So since that means that my vector u can have a scalar of plus or minus 2 using the unit vector that I have up here, which was, we found to be 3/5, 4/5, right? So this is 3/5, 4/5. So the two vectors, I can have two different vectors that will have a magnitude of 2. And that would be the vector, first vector I'll have is going to be 6/5. So 6/5 when I use positive 2, and 8/5, right? And the other vector that I could possibly have, we could call this vector 1, vector u2, and this would be just the opposite direction of this, and that'll have a magnitude. There we go. Sound good? All right, so let's go ahead and look at another problem. Good, and it asks us, show that the 0 vector and any other vector are collinear, right? So if they are collinear, right, if we have the 0 vector, right, the 0 vector has component 0, 0, right? Good, then it would have to be, that means u is equal to some scalar times that 0 vector, or better yet, the 0 vector is going to be some lambda times some other vector right here, if we can show that can happen. So so let's say if I let u equal use of 1, use of 2, the vector use of 1, use of 2, then I know the 0 vector, right, to be components 0, 0, right? Well, that's the same as, I can write that as 0 times use of 1, 0 times use of 2. That's the exact same thing, right? And then I can say 0 times use of 1, use of 2, right? And that's for any vector that I have here. So therefore I know the 0 vector is collinear to any vector. Sound good? Thanks, guys.